So we have a sequence which is given by 2 raised to the power of n plus 3n, where n is a set of natural numbers. So here an, this represents the nth term of the sequence. We need to find the sum to n term. So let's begin. First, for n value equals to 1, we can obtain the first term, which will be equals to 2 raised to the power of 1 plus 3 times 1. So that gives us 2 plus 3. We're not going to take the sum, we'll just keep it as 2 plus 3. Then the second term will be for n equals to 2. That is going to give us a2 equals to 2 squared plus 3 times 2. We'll have 2 squared plus 3 times 2. We will not simplify this. For n equals to 3, we're going to get the third term, which will be 2 cubed plus 3 times 3. So let's find out the sum. The sum up to the nth term will be a1 plus a2 plus a3 all the way up to the nth term. So our first term, so that came out to be 2 plus 1. So 2 plus 1 is also 2 raised to the power of 1 plus 3 times 1, plus the second term, which is 2 raised to the power of 2 plus 3 times 2, plus our third term, 2 raised to the power of 3 plus 3 times 3. This goes on and on to the nth term, the last term, which is 2 raised to the power of n plus 3 times n. So what we will do, we will combine all the terms which have the powers of 2. So we have 2 raised to the power of 1 plus 2 squared plus 2 cubed going all the way up to the nth term, which is 2 raised to the power of n. Plus we will combine the remaining term by taking 3 as the common factor. We have 3 multiplied to 1 plus 2 plus 3 all the way up to the nth term, which is n. Now we have our first term. So this is a geometric progression. So this is a geometric series with our first term equals to 2 and the common ratio equals to 2 squared divided by 2. So that's going to be simply equals to 2. So that means we can find out the sum. Our sum will be equals to, so we'll use the formula for the sum. So let's note it down as n equals to a times r raised to the power of n minus 1 divided by r minus 1. So here our value is 2, which is greater than 1. So let's plug in the value. So we have our first term to multiply to r, which is 2 raised to the power of n minus 1 divided by r minus 1, plus 3 times. Now 1 plus 2 plus 3, this is an arithmetic progression. So that means the sum of this arithmetic progression up to the n terms, we will be using the formula, the Sn equals to, note it down, for the arithmetic progression. This will be given by n over 2 multiplied to the first term plus the last term, which will be equals to, so we have n number of terms, so we have n over 2 divided by 1 plus n. So this will be equals to n times n plus 1 over 2. We have 3n multiplied to n plus 1 divided by 2, which gives us 2 times 2 raised to the power of n minus 1 plus 3n over 2 times n plus 1. So this is going to be the sum up to the nth term of the given sequence.